what is the assumption that we make when we run k nearest neighbors? Well, let's start with k equals 1. What's the assumption that we're making? Well, the assumption that we're making is that if you have a point here, then its label is going to be related somehow to the labels of the points that are near it, right? And by points that are near it, we mean points whose distance to it, the Euclidean distance, which you just compute using something like, the sum over xij minus ti, where xij is the ith coordinate of the jth training case. What you mean is that if you try to make this small, then the label for the label yj is going to be similar to the label of the test point. At least on average, that is what we hope. But of course, nobody said that this is going to be necessarily true for any kind of set. For what kind of set would it not be true? Well, the way to put it is, well, if it so happens that the label of a point is completely unrelated to the labels of the points that lie near it, well, that means that k nearest neighbors is just not going to work, except for the case of on the training set with one nearest neighbors or few nearest neighbors, where you're just looking at your own label. Of course, if you're running k nearest neighbors on the training set, that's cheating. So, okay. So how should we put it? How can we formulate this kind of more precisely? Well, what we can say is, all right, let's say that you have a set, and the set looks kind of like that. So it's going to be xi and yi, and in general, it's going to start from x1 and y1, and it's going to go until xm, ym. So what we want to say is that the distance between the points should have nothing to do with the labels. So one way to put it is to just say, well, maybe the set is generated probabilistically, which means that the way we put it is we say, all right, so the distance between xi and xj, which could be generated probabilistically as well, right? If you're generating xi and xj probabilistically, the distance, you can just derive it from there. And what you would say is that this distance, well, it should be independent of the y's, right? So it should be independent of whether the y's are equal. So we would say yi is equal to yj. So this is just a fancy way of saying that the distance between the x's has nothing to do with how similar or different are the y's. If that is the case, what's the curve going to look like if we're going to try to plot the performance, versus the k on the validation set? Well, if it's the case that the label has nothing to do with the labels of the neighbors, that means that if you're using k nearest neighbors, the best you can hope for is that it won't screw things up. What do I mean by that? I mean, well, the baseline is to just say, well, let's do a majority vote of the entire training set and see what's the majority, and that's going to be our output. Okay? How can you screw it up with k nearest neighbors? Well, the output for k nearest neighbors is going to be kind of noisy, right? Because here, if it's the case that the label has nothing to do with the labels of the neighbors, what you should say is you should say this is green and this is green and everything is green. But of course here, if you're using, for example, one nearest neighbor, then you'll say, oh, this is pink, but this is green. So the performance on that should be worse because what you'd expect is that, this is green with probability 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with 10 divided by 1, 2, 3, 4, 5, 6. So with probability 10 by 16, this should be green, assuming that you can't actually use the fact that the neighbors are mostly green because we are assuming that this is irrelevant. Here it does not seem like it's irrelevant, but we could very well imagine a data set on which it would be irrelevant. Okay? So what it means is that eventually the performance we'll get to be the ratio of the correct label to the size of the training set. Here you'll start out with some kind of bad performance, and it'll just go up like that. Of course, in expectation, right? So there might be random variations, but it would be something like that. So this is what you would expect, and that's kind of the answer to the question on the midterm.